Hello, we're going to see right now template matching. What is it? For example, let's take an image. I took this one from Simpsons and a template which is Bart's face. So exactly, I'm doing some mess with my computer. Okay, exactly this part. So I cut the Bart's face from the image and I took another image. So this is going to be our template. And with template matching, we are going to find the location of this template in this image. So let's run the code. Actually, let's write the code. So we import CV2, import numpy as np. We load the image cv2.imRead simpsons.jpg, and we load the template equals to cv2.imRead bartface.jpg, and you can download both template and images from the link that I put in the description, or even better, you can use your own image and your own template. After this, let's show the image cv2.im show emg cv2.wait key 0 cv2.destroy all windows. Okay, here we have the image. Actually, let's even show the template cv2. Actually, no, it's not necessary to show the template. To use template matching function, we need to use both template and image in grayscale format. So let's create gray emg equals to cv2.cvt color. We want to convert the image to cv2 color underscore bgr to gray. And also for the template equals to cv2.cvt color template cv2.color underscore bgr to gray. So as you can see, for the image we change the name, we create a new variable gray image, because actually I want even to show the original image, so I want to keep them both. For the template, I'm just changing the color of the original template in grayscale, because we don't actually need to see the template in the original color. Actually, you could do something even much more simple, which is load the template already in grayscale format. So cv2.imRead grayscale. Let's move on. Now we can already start finding the template. So we will have the result equals to cv2.match template. First we put the image, second actually gray image, second the template, and the method. There are different methods. We're going to see just one, the one that I've seen it works the best, which is tm underscore ccoeff underscore normed. And let's show this result, cv2.im show result and result. Okay, so this is the result. What is this exactly? So in on the image you can see some different shadows, some black background, and then we see this white point. This is exactly what we need, which is the top left of the template matching. So this exactly will be, let's show, okay, Bart's face. It's exactly this point which is matching exactly this area, and after we match this point we can draw a rectangle to match all the template. So to do this we need to find a threshold. Okay, let's first print the result so you can see. Print result, and we see what's inside this array. So these are all the values. So the image that we are seeing here is the result of all these values. Actually it cannot show all of them, where these dots, there are thousands of them still. So somewhere you can see 0.1, 0.05. The greater this value is, the more it's going to be white. So 1 is going to be completely white. So we need to find the highest. For example, in this case we can say that this white point can be something like 0.8 or 0.9. So we want to find the location of this white point. So it will be log, it's equals np dot where result it's greater or equals to 0.8. Actually 0.8. So let's print log. Okay, here is giving us the exact location of that point. You can see we don't have an exact number because the point it's not really clear. So if we want something only one point, we need to give higher threshold like 0.9. In this case we have one exact point, so we have 44 and 478. Now that we have this, let's draw this on the original image. So we need to unpack this array with the location points. So it will be something like this, 4 points. So let's say pt in log. In this case we need to unpack this array, so we have this function zip asterisk, and let's close the parentheses. So let's print the point, let's see what we get. Okay, 44 and 478. 44 and 478 is exactly this, the location of this point. Now we need to draw a rectangle. To need a rectangle, we know that we need 2 points. First is top left point, this one that we have, and second one right bottom. So we need this exact point. How can we calculate that point? Well, it's really simple. We know that if top left is this one, bottom right is this one, so we can add to this point the width of the image and the height, and we will find this point. So first we need to get width and height of the template, which will be this way. We have width, height, it's equals to template dot shape, and then this, it might seem scary, but exactly this is saying to invert the order. So it's usually we have rows and columns equals template dot shape, and as we know the rows are the height and the columns are the width. So now we want just to work with height, and usually we use width the first value and height the second. So we are just actually inverting the order. So nothing really special. So let's draw the rectangle cv2.rectangle on the original image. Then we have the first point, so it's PT, and then the second point, so we need to get the first value PT0 plus the width and second value plus the height. The color, I'm going to make it green, so BGR it will be 0 blue, 255 green, 0 red. The thickness, let's say 3. Let's show the result. Actually, let's hide this result. Let's show the original image. And the result, it really sucks. Why? Let's check. Probably there is some mistake here somewhere. Yeah, for sure I did some mistake. Result degree image template. That's strange. Let's give a different threshold. Well, I did some mistake. I cannot figure out what's wrong in this. Okay. The location, even in this one, I need to invert the order. So actually I'm inverting X and Y axis. So as we did before, it's -1. Okay. So I was inverting the axis, so that's why it was this location. Okay, now we get the right template matching, and we can change if we want threshold if the image is not so clear. So 0.6 still it works fine, but if we give low threshold, for example 0.4, it starts already finding more points. Okay, we have this. Let's, for example, right now work live with the video, so let's try to match some template in real time. So let's clear this code and let's work. Okay, let's get the camera. So import cv2, import numpy as np, cap it's equals to cv2.video capture 0, template equals to, actually I'm going to put the template letter, while true underscore frame it's equals to cv2.cap actually not cv2 cap.read cv2.imShow. Let's show the frame. Let's create a key event, key equals cv2.wait key 0, if key it's equals to 27, so the S key on the keyboard will break the loop. and cap.release cv2.destroy all windows. Okay. Okay, some mistakes. Wait key not 0 but 1. Okay, this is me, it's working. What now? I created template. I'm going to show you the template. So I have this pen and I took a picture of the pen. The quality really sucks, but it's okay for this video. And I'm going to use this as template. So you should create your own template based on what you have. Template it's equals to cv2.imRead pen.png, and let's read this grayscale format, cv2.imRead grayscale. So let's find the result. It's equals to cv2.match template of the frame, but we need to work with gray frame, so gray frame it's equals to cv2.cvtcolor frame and cv2.color bgr to gray. Match template of the gray frame template and the method cv2.tm underscore ccoeff underscore normed. After we get the result, we need to find the location of these points. So log is equals to np.where, whereas it's greater or equals, let's say 0.6, and we need to draw these points. So for points in location, actually this zip asterisk log and -1 cv2.rectangle. So on the frame we have the first point, and the second point we need to get width and height of the template. Width height equals to template.shape and so second point is pt0 plus width and pt1 plus height. The color, let's make it green, 02550, and thickness is equals to 3. Okay, we have already some error because I gave a low threshold, so it's finding the wrong template. But anyway, we're interested in the pen, and you can see that it works not really well. Let's give a higher threshold so the image must be more precise, the matching must be more precise. Okay, and here we have the match, and of course it must be exactly the same position. You cannot put the pen. Okay, in this case it works because it's really similar, but for example if you put it like different, it doesn't work. It must be the template matching works when the template is exactly as the original image, even like the rotation must be exactly the same. In this case it can be similar because we gave a lower threshold, but if you see, if we give really low threshold, then it is not going to work at all. It's going to find some a lot of errors, a lot of mistakes. So probably even 0.8 here can be okay, but I'm not sure. as you see, it's really, it doesn't work. Even because when I took the template, the lighting was a bit different. And so this is all for this video, and thanks for watching.